Alright, today we'll be doing the hardware portion of the lab, and I'm going to go through the hardware section in the lab manual. So I'm going to start from part A through part part O. Okay, so we'll do that. And part A, it states here that figure 2-2 shows the test jig used for this experiment called saturator, using the circuit shown in figure 2-1. Alright, so last week you did the simulation of the test circuit. That's figure 2-1, and when you actually built the circuit, it will look something like this. Or this is actually our version of that circuit. We built that circuit and we use this circuit to do this experiment. So this is a test circuit that uses the schematic that you simulated last week. So this is part A. Okay. All right, so part B it says to obtain 2/2 of an ETD29 core, material 3C90. So we have a selection of cores here, and this is how ETD29 core looks right here and right there. So 2/2, right? So what we're gonna do later, we're gonna put the 2/2 together, right, to form the core, right? And then, yeah, this is very brittle, so if you drop it and hit the table here, it'll just break. And then that's part B, right? Getting the ETD29. So this is what it looks, how it looks. Okay, ETD29. Oh, sorry. And then you can see that in ETD29, the center part of the core is a circle, cross-sectional area. So it's not a rectangle like the other two legs, right? But the center leg is a cylinder or circle cross-sectional area, right? And then part C, it's asked to cut sufficient amount of gauge 26 wire. So that's this gauge right here. I have a different color. I have a green color somewhere, but this is an example of a gauge 26 wire. It's this thin. I don't know if you can see it, but this is still new. So like that size. Okay, that's gonna be the wire that we will be using to create the coil, right, for the inductor. Okay, so that's gauge number 26. And then part D, it's asking for us to wind 25 turns on the bobbin. All right, so bobbin. So here's the bobbin for ETD29, right? So every single core will have their own associated bobbin. What is a bobbin? So a bobbin is it's like a place for us to be able to put these 2/2 together, right? I think that's going to be part E, so I'm going to do part E as well, right? So part D is to wind the 25 turns on the bobbin, and then you can see that again there's a place where we can put one half of the core into the bobbin that way, right? And then you place the other half on the other side, and you can see that those fit nicely into the bobbin, and this enable us to have a stable a stable formation of this inductor, right? And then in addition to the bobbins, right, you also need the clips, right? So the clips is here to be able to because right now it's kind of loose, right? If I just let go, then it'll come out. So then you're gonna need clips like this, right? Then for ETD29 bobbin, the clip looks like this. I forgot to show you. That's the clip. There are two clips, right? So what you do is on top of the, so I'll redo this, right? That's the bobbin, and I'm gonna insert the core that way, right? And then I'm gonna take away this one first, right? So now you have 1/2 of the core, and I'm gonna put the the clip this way, and it should oops, you know what, I'll do both first. We'll do both. Insert the other one here as well, and then I'm gonna put the first clip, kind of tricky to do so, right there. That's the first, or that's the top side, if you will, and then the bottom side I'm gonna put the other clip that way. Oops, let's see, sometimes it's easier to do it one way or the other. There you go, until you hear that click. So now you can see that the two cores are, there you go, are you know, put together tightly because of those clips. Okay, and again, back to the bobbins. So bobbin has the function of where you place the two half of the core, so you can combine them, you can place them together. That's the first function of the bobbin. And number two is allowing us to have the, you see that center part, easier way to wind the wire, right? So imagine I wind the wire that way and out this way, right? And the third function of the core is that it allows us to have external connection, electrical connection to the inductor, right? So you need to be able to what do you call it, inject current right through the inductor, and that would what do you call it, that would allow flux to produce in the core, right? So imagine you have a piece of wire, right, and then you would wind the wires around that core, and one end you would extend it this way, the other end you would extend it the other way, right? And those two ends are the ones that are going to make the electrical connections to the rest of the circuit, right, as an inductor. So so you could tie those ends to these pins right there, right? So you can tie them up like that, and that would make a more stable connection, electrical connection to the outside of this inductor. Okay, so that is actually part E, right? So I just did part B through part E, right? Except I have not actually cut the wire. So the next thing I'm going to do, I'm going to cut the wire, the 26 wire. I'm going to start making the winding, and it says here to do it 25 turns. So that's what I'm going to do, right? 25 turns, and then after I'm done, I'll show you the finished product. Okay. Okay, so here's the finished inductor. As you can see, I have the 25 turns in the middle right there, right on the center leg, and that makes the inductor. And you can see I have some extra wires that I connect to one of these pins to make a stable connection to the that I will connect to this board. Okay, so I use this what do you call it, the head pins, and I'm going to connect this inductor to here. And if you look at the test jig, you can see, hopefully you can see that we have the place where I can connect the two ends of the inductors. See that? Coil P1, coil P2. So I'm going to connect those there. Okay. And then remember that last week we have the two voltages, X and Y. There's the X and there's the Y, right? Again, X is for magnetic field intensity, right? And we're going to measure voltage at X that represents magnetic field intensity, and then we're going to measure another voltage, Y, that that represents flux density, right? B. That's going to be a voltage that is going to be proportional to flux density, right? And then we'll we'll use oscilloscope later on to see the BH curve, right, using those two voltages. Okay, so again, keep in mind that those voltages are, you know, scale down or scale up version of the either for X is field intensity, for Y is the flux density. Okay, I just finished making the connection from the power supply to the circuit, and then also from the pulse generator to the circuit, as well as the oscilloscope to the XY, you know, probes. So next I'm going to show you the connection, and also the waveform that I have, the BH loop that I have on the scope. Okay, as you can see, connection is kind of messy, but you can see here's the inductor, right? And I'm connecting the inductor to the test jig right there, like coil P1, coil P2, and then I'm also connecting the circuit to the power supply right there, right? And then also the function generator, which is going to give us the pulse into the test circuit, right? And as you can see, both the pulse generator and the power supply are connected to the circuit. Okay, and the way I'm connecting the power supply, I have a dual power supply right here, and it's giving out plus minus 12 volts. So the one on the left right there, that's going to give us the plus 12, you know, plus minus 12, and then the one on the right, that's going to give us the minus 12. So here's the minus 12 line right there, and here is the plus 12, you know, rail right here, and it has the same common, you know, connection right here. Okay, and that goes into, you know, the plus and minus. Here, here's the plus. Oops, sorry. Here's the plus of the test jig, and here's the minus 12 input of the test jig. Okay, and then for the function generator right there, as you can see, I'm putting 10 kilohertz frequency, amplitude of 20 volt peak to peak, and duty cycle of 50%, right? And I'm using the T connector so that I could you know, monitor the pulse, as you can see, coming out of the function generator, and at the same time sending the pulse into the circuit right over here. Okay, so here's the SIG input. It's upside down, but you can see that's a SIG input, and there's the ground. All the grounds are tied into the same point. Kind of messy, but that's what we have right now. Okay, and then the scope, we have two channels. The channel 1 is for the X, right, voltage right there. Oh, I don't know if you can see, but you know, these two right here, you know, the one on the right, that's the X, the one on the left is the Y, right? So channel X or channel 1 goes to the X probe, and channel 2 goes to the Y. And you can see I have, you know, this beautiful BH curve, as you can see. Let's see, so you have to do the XY format of the scope, right? And then there is the BH loop, and you can see the scale, the voltage scale for channel 1 and channel 2. Okay, so you can go ahead and capture this, and perhaps from here you can measure the mu, okay, the permeability of this core. Okay,